in the previous section, I mentioned that any equation of this form could be solved using the complete the square process. However, some are going to turn what I called ugly in the sense that fractions would be involved. So this process, using this formula, called the quadratic formula, is another way to go about working with these equations so that you don't have to deal with all the fractions in that complete the square process. So it involves using the values of a, b, and c plugged into the following formula. Now, if you've never seen this formula before, it is a bit to memorize, and that is really your first step. You do want to memorize this form, whether it's by writing it out a bunch, just looking at it, reading it a bunch of times, or I will say that there is a tune. If you take this particular equation and match it up with the Pop Goes the Weasel song, you can find a couple of variations of that on YouTube where I think it's pretty catchy and can get stuck in your head pretty quickly. I'm going to do my best to sing it once for you here, although I would advise just muting it for the next 20 seconds and then going and finding on YouTube instead. So the formula can be memorized with the song. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. That's what you're going to hear on YouTube as well. And so with that equation and that formula, we can take that to any of these equations. Again, making sure we get it into this form first, and then simply plugging in and simplifying. So, with the first one here, notice it's not in that form yet, so the very first thing we do is we get it into that form by bringing the 3 on over. Now we have our a, our b, and our c for the problem, and we can take those values into our equation. So we get x is equal to the negative of b, so b is negative 11, plus or minus the square root of, now it's b squared, so negative 11 squared minus 4 times a times c, making sure you get all these signs. Every one of these signs can make all the difference, all over 2 times a, so 2 times 4. Okay, so let's go about simplifying this a bit. Negative of negative 11 is positive 11, plus or minus the square root. Negative 111 squared is 121, and 4 times 3 would be a 48. We had a minus sign, but there is a negative, so those multiply to a positive, so it'll be a plus 48 all over 2 times 4, so 8. All right, I'm gonna bring this back up here. X equals 11 plus or minus the square root of, so I'll get 169 if I add those two values together, over 8. So that'll be 11 plus or minus. Now, just so happens that 169 is the square of 13, so the square root of 169 works out very conveniently to the number 13, over 8, which means that plus or minus can now be separated to 11 plus 13 and 11 minus 13, which actually have a nice value. 11 plus 13 being 24 over 8, and 11 minus 13 being a negative 2 over 8, giving me x equals 3 and x equals negative 1/4. So 3 and negative 1/4 would be the solutions to that original equation. And I'll go ahead and point out again, that nice of a number, again, those are rational, meaning they can be written as fractions, right? No radicals at all, no square roots anywhere, or imaginary numbers either, right? So what's that tell us? That tells us that, again, this would have factored. We could have actually brought this minus 3 over and done a bottoms-up approach there. But I just wanted to show you what this process would look like if, indeed, that turns out nicely and you do get those nice rational solutions. All right, let's take a look at some more. So same thing, I will bring over the 14x this time, subtract 14x to get it into that form for my a, b, and c, and then plug into the formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And then let the simplifying begin. 14 plus or minus the square root. We have 14 squared. $196, and then 4 times 2 times 19. So that'll be a minus 152 all over 4. Doing some more simplifying, that'll be plus or minus the square root of, we'll get a 44 there after we reduce, after we try to simplify. And then I'll bring this up top where we can take that square root of 44. And for 44, notice 44 would be a 4 and an 11. And that 4, the square root of 4, would bring a 2 out front with the 11 still inside. Now with that, what we want to point out is this 14 and this 2. Those numbers, they have a GCF of 2 involved, and the reason that's important is because we can actually factor out that 2, leaving me with 7 plus or minus root 11. If we factor that 2 out of both those coefficients there, and that 2 now can cancel with that 4 to a 1 and a 2. Giving us a more reduced final answer of 7 plus or minus root 11, and a denominator only being a 2 down there. Giving us 7 plus root 11 over 2, and 7 minus root 11 over 2 for our final answer. So again, what just happened right here was we got to this point, and we said, to see if this is going to be reduced, could we find a factor of the numerator that reduces with the denominator? And so 14 and 2 had a factor of 2, and that 2 reduced with the 4 to a 1/2. And you didn't need to write a 1 out front of this, so we just wrote that, and then over the 2. All right, so for the next one, we already have the correct form. All things on one side equal to 0. So as far as A, B, and C are concerned, we've got x equals the negative of negative 6 plus or minus the square root of negative 6 squared minus 4 times 1 times 10 all over 2 times 1. So we've got 6 plus or minus square root. That'll be a 36. That'll be minus 40 over 4. So that's 6 plus or minus the square root of negative 4 as a leftover there in the radical. Now, with that, square root of negative 4, two things. First of all, the negative on the inside will turn into an I on the outside for an imaginary number. And the leftover of square root of 4 will work out nicely. We can just make that all turn into a 2i all over 4. Now again, with these terms, if we're trying to reduce, I'll look at 6 and 2. And I'll say they have a factor of 2 in common. Factor out of 2 from both those terms leaves you with just 3 plus i. But that will then allow you to cancel or reduce with that 4 to a 1 and a 2. Leaving you with just 3 plus or minus I and a 2 in the denominator. So we'll have 3 plus I over 2 and 3 minus I over 2. All right, and the last one here, we will get it into the correct form first. Subtract that 8r on over to there. Then we've got A, B, and C. And so we've got x equals negative of negative 8 plus or minus the square root negative 8 squared plus or minus 4 times 1 times 16 all over 2 times 1. So that'll be the negative of negative 8, which will be an 8, plus or minus the square root of 64. Oops, that should not be a plus or minus. It should just be a minus. My apologies. Minus 64 over 2. And right here, what we see is we've got plus or minus the square root of 64 minus 64. Well, that's going to be 0. The square root of 0 is 0. And I'll write it, but if I write plus or minus 0, that doesn't give us two different values, right? 8 plus 0 or 8 minus 0, that's both just 8 over 2. So that gives us a single solution of just 4. And let's point out again, that's a nice number, right? A nice rational value. No radicals or imaginary numbers involved. What's that tell us? That tells us this original equation could have factored. And specifically, the way we're getting only one solution here, this would have factored into a binomial squared. Notice this would have factored into just x minus 4 times x minus 4, so that's why we're only getting one solution there.